So we just calculated the peak power consumed by a 250 ohm light bulb, a light bulb modeled as a 250 ohm resistor. And for 170 volt peak waveform coming out of the power outlet, we calculated that peak power to be about 120 watts. And we asked ourselves, what is the average power coming out of the light bulb? All right. So time average power we actually discussed a little bit when we were talking about lifting weights earlier in the semester. And perhaps you remember that you can calculate average power if you take the area in the power curve in some period t and divide that by the size of the period. You will get average power. All right, so let's take a look at our example. If we plotted average power for a cosine waveform, we would get the average power that behaves something like cosine squared, where this is the P max and this is 0. All right, so notice that the frequency would be twice the frequency of the voltage waveform, and you can think about that, but this will be 1/120th of a second. All right, so we can use a trig identity here that cosine squared of some function omega t equals 1/2 plus 1/2 cosine of twice the frequency to omega t here. All right, so to calculate the average of cosine squared, we would use this identity here, and we could notice that the cosine part of this identity would average out to 0, and so the average power would just be half of P max. So for a sinusoid, P average is 1/2 of P max. All right, using this trig identity. This is for sinusoid. So remember that light bulb that had the peak power of 120 watts? That P average of that light bulb, let's use consistent labeling here, is then 1/2 of 120 watts, which was in the previous video, would be 60 watts. Okay? And see previous part. See previous part of the video for that. All right. Sometimes, and this is a somewhat more advanced topic, we can also talk about the average power for non-periodic signals, okay? And this is important when we talk about noise. So that waveform might look something like this, and we can collect some statistics about the noise and maybe just calculate the area under the curve. This is instantaneous power for some long period of time, and then divide it by that period of time, and we would get an estimate of average power of that noise given certain conditions. And I guess it's described more in courses like EC 313. All right, about you'll learn more about noise power, and maybe EC 359. I think maybe it's 459 actually. communications course. All right. Okay. So we'll continue in the next part.